Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 1290. Convert binary number in a linked list to integer. Give one head which is a reference node to a single linked list. The value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number. Return the decimal value of the number in a linked list. The most significant bit is at the head of the linked list. So they have clearly given that the most significant bit is the head of the linked list. So it is in the right order when we take the numbers. Okay. So let us see first what is meant by binary representation. Okay. What is meant by binary representation? So in binary representation, we represent in by form. That means in zeros and ones. A number that can be represented in 0 and 1. Okay. Now, how to convert this binary into a decimal? Because that is a question, right? That's a question. If I have given you a binary representation as 1001, let us take or else 1000. The binary representation will be written like this, base of 2. Okay. Now this can be converted as, just listen carefully, this first zero into 2 power 0, this second 0 into 2 power 1, here 2 power 2, here 2 power 3, 0 into anything, 0 0 0, and here it comes what? It comes 8. So 8 plus 0 plus 0 plus 0, which is equal to 8. So what is the decimal equivalent? It is 8. Can I understand this? Yes. So this is how we will convert a binary number into a decimal number. Okay, it is fine. Now let's go into the example part. See here, this is an example 101. They have clearly said that what the most significant bit, the most significant bit and least significant bit. There are two types of bit, and see here, this is the most significant bit, the most significant bit, and this is the least significant bit. Clear? Now they have given that most significant bit is at where? At head. That's why I have told you that the number is as it is taken and it can be converted. Okay, because see here 101, take this 101. Okay, by doing this stuff it will use a result of 5. How? 1 into 2 power 0, 0 into 2 power 1, 1 into 2 power 2 is equal to 4 plus 0 plus 1 is equal to 5. Clear? Yes. Now how to approach this problem? It is quite simple, right? What's the first approach? Always a brute force approach is, see here, it is very simple. Just take each and every node, just traverse one by one, just traverse one by one, and take the each and every values. Yes. Then put into an array, like this, 101. Okay. Now do this procedure. But how? Just see here, traverse from the reverse order, and take this 1 and multiply with 2 power 0. Then take this 0 and multiply with 2 power 1, and take this 1 and multiply with 2 power 2. Yes. So this will be my brute force approach. So what is my time complexity and space complexity for this brute force approach? Now see here, what's my time complexity? It is, just observe carefully, my time complexity will be O of n, right? Because I am traversing each and every nodes one time, and also I am traversing each and every values in the array. So it is O of 2n, which can be written as O of n as a constant. Okay. Now what is the space complexity? It is also O of n. Why? Because we are using a auxiliary space, array space, right? Now the second approach is, just imagine if I have a linked list like this. Okay, just imagine. Now I want to access this linked list from here, right? From head only we can access, and in single linked list we can move in this way. That's why we have taken into the array, then we can move in this reverse direction. Then this is multiplied with 2 power 0, this is multiplied with 2 power 1, this is multiplied with 2 power 2. Okay, why can't we take the length of the linked list and do power with 2 and multiply with the value? Just come up. See here, what's the length of this linked list? Just traverse 1 2. Initially it will be 1, right? And it will be 1 1 2. Okay, 3. So the linked list length is what? 3. There are 3 nodes. Yes. And then just observe, what should I put in the power of 2 in this, at this node? At this node value, it is 2, right? 2, right? So take this node value, and then do a multiplication operator with power of 2 comma, what is the length? Length is 3, right? So length is 3, and then I have to do what? At first it will be 2, then 1, then 0. So take length minus 1, and in each and every iteration just reduce my length by 1. That's it, right? First it will be 3, then 2, then 1, and whenever here comes, it is length minus 1. So whenever it is 2, it will be reduced to 1. Fine. So I will take this as a result. Plus is equal to result. Can you understand this? Yes. Okay. Coming to time complexity, the time complexity of this approach is n. Okay, and then space complexity is O of 1. Okay, we can also do without this power function. But how? Because this power function will have a some time complexity. Okay, still it have some more time complexity. It is an inbuilt function. Okay, in most of interview cases, they says that you don't want to use this power function. Okay, in those scenarios, just come up with another solution. Like it's not a different approach. It's same as this approach, slightly different. Like when you are traversing in this linked list. Okay, when you are traversing in this linked list, initially keep the value as 1. Okay, then multiply with 2, then multiply with again 2, 4. You got 4. Now take this 4 and multiply with this 1, and then reduce this 4 by 2. What is the value? It is 2. Now take this 2 and multiply with this 0. Again reduce this 2 by 2. What is the value? It is 1. Again multiply this 1 with 1. What is the value now? It is 5. Can you understand this? It is quite similar to this approach. Just because of this power function, we instead used it. Just take a variable called multiple. Just take this variable which is equal to initially 1. Whenever you are traversing to the linked list, to the linked list, just make this multiple into is equal to 2, which means multiple is equal to multiple into 2. Okay, and then again when you are traversing, just take result plus is equal to node value into multiple. Okay, and then multiple divided by 2. That's it. Okay, so this will be my code. Okay, fine. Now can we do without this multiplication and the power? That's another method. Okay, it is what a third approach. The third approach states that, just observe carefully, we can do this without using what? Length. Without knowing the length, I can find. But how? But how? Just come up with me. It will be more easy. Just come. See here, 1, 0, 1. Okay. Now, initially, at first it will be 1, right? Just take result is equal to 1 at the first. Now, when you are going here, okay, it is the second place. Okay, from here, if we see this 1, it will be what? The second place, right? If just ignore this, node here, 1 and 0, then this 1 should be what? That 1 should be 2 power 2, right? So I will do into 2 plus 0. Can you understand this why I have done this 2, right? Because whenever we are shifting towards this side, each and every time a multiplication of 2 will make this as my next value. Okay, now it will be what? 2. Again come here. When you are coming here, this 1 and this 0 will be shifted what? Shifted one time in the left side, right? Shifted one time in the left side. So again do this with a multiplication of 2 plus, what is the value? It is 1. Now what is the value? 5. Is there is any other node? No, right? So this is my output. Can you understand this? Just observe carefully. I will say this again. See here. Initially this one. Just forget about this. Okay. Initially it is one. Now I have to add. I have when I am traversing to zero. What I will do? Just right shift it. Sorry, left shift it. Left shift. It will become what? 1 0. When we are left shifting, it is equal to what? Multiplication of 2, right? Again, if we are connecting this one, then again I will left shift this by 1. Again I will multiply by 2. Then I will put this one. Can you understand now? Yes, when we are seeing the code, it will be more clear. And I also try run it. Okay. Now, this is what optimal approach. It is also O of n and space complexity is O of 1. Okay. In this approach, we don't want this length. We can traverse only one time. Here we will traverse 2 times, right? Because we are finding the length. So it will be 2n. But constant, so we don't take it. But here we are just traversing only one time. There's no much difference, but still this is the optimal approach. Let's see the code. See here. This is the length approach. Okay. First of all, I am assigning the current is equal to head, then length is equal to 0, then I am finding the length, just traversing one by one. Now, current is equal to head, then see here, result is equal to 0, while current is not equal to null, result plus is equal to current dot value into power of 2 comma length minus 1. I have told you, right? I have told you. And we down length minus equal to 1, then current is equal to current dot next, traversing one by one node, then I am returning the result. Okay, so this is what the power approach. Try by yourself about that multiplication variable. Okay, let me run it. First of all, I will comment this. Let me run it. Yes, it is submitted successfully. Now let us see the optimal approach. Okay, see here, this is the optimal approach. First of all, current is equal to head, then result is equal to 0. Now, while current, result is equal to 2 into result plus current dot value. I have told you, right? Because, see here, whenever we are moving to the next node, the previous node is what? Left shifted one time. So that. Now, current is equal to current dot next. Now, return result. Just come up with this example. See here. First of all, what is my result? It is 0. Now, what is my current dot value? It is 1. Initially, it is 1. Now, 2 into 0, it is 0. Now, plus 1. Plus 1. So, it is what? Now, result is 1. Now, again, my current node will be where? At 0. Okay. My result is 1. Now, result is equal to 2 into result. So, it will be 2 plus 0. Clear? Clear? Now, again, my current node will be where? At 1. Now, result is equal to 2 into result. Result is what? 2. So, 4. 4 plus 1 is equal to 5. So, 5 will be my output. Can you understand this? Let me submit it. Yes, it is submitted successfully. Thank you.